Marcus Chen sat in the back row of the Galactic Military Academy's Advanced Weapons Theory classroom, trying to make himself as small as possible. At 6 feet tall with broad shoulders, this was no easy task when surrounded by beings who averaged 4.5 feet in height. The Zalari instructor, Professor Kethvar, had mandibles that clicked disapprovingly every time Marcus shifted in his seat. "Today we examine primitive projectile weapons," Professor Kethvar announced, his 4 arms gesticulating wildly as holographic displays materialized above the classroom. These crude devices represent the early stages of military development across most civilized species. Marcus watched as images of various alien weapons rotated slowly in the air: crystalline spears that hummed with energy, metallic discs that could slice through armor, and sleek dart throwers that fired poison-tipped projectiles. All of them were clearly manufactured, precision-engineered, and deadly. "The key to understanding primitive weapons," Professor Kethvar continued, "is recognizing their limitations. Crude materials, imprecise manufacturing, limited range and accuracy. This is why most species quickly abandoned such devices once they achieved basic metallurgy and energy manipulation." A student in the front row, a tall insectoid Thraxian, raised one of her 4 arms. "Professor? What about species that never developed beyond these primitive stages?" Professor Kethvar's mandibles clicked in what Marcus had learned was the Zalari equivalent of a chuckle. "Excellent question, Student Zixtra. Such species typically remained confined to their home worlds, eventually going extinct or being absorbed by more advanced civilizations. They simply lacked the innovation necessary for true military advancement." Marcus felt heat rising in his cheeks but kept his mouth shut. He'd been the only human accepted into the academy this cycle, and every day reminded him that most of the galaxy considered his species barely above primitive. Humans had only achieved faster-than-light travel 50 years ago, making them the newest members of the Galactic Federation. Most species had been traveling between stars for thousands of years. "Now," Professor Kethvar said, his purple eyes scanning the classroom, "I want each of you to consider the psychological impact of primitive weapons. When faced with advanced energy weapons and kinetic shields, how would a primitive projectile weapon affect an opponent?" Student Zixtra answered immediately. "It would have no effect, Professor. The psychological impact would be negligible, because the weapon poses no real threat." "Precisely," Professor Kethvar clicked approvingly. "Fear comes from genuine threat potential. A primitive projectile weapon would be dismissed immediately by any properly trained military mind." Marcus found his hand raising before he could stop himself. The classroom fell silent as every alien eye turned toward him. Professor Kethvar's mandibles twitched with what Marcus interpreted as barely concealed annoyance. "Yes, Human Chen. You have something to add?" Marcus stood slowly, feeling the weight of dozens of stares. "I think you might be underestimating the psychological impact, Professor. Sometimes the most effective weapons aren't the most advanced ones." The classroom erupted in a series of clicks, chirps, and whistles that Marcus recognized as alien laughter. Professor Kethvar raised 2 of his arms for silence. "Human Chen, I appreciate your enthusiasm, but you must understand that your species has limited experience with true military conflict. The psychological impact of weapons has been thoroughly studied across thousands of species and millions of conflicts. Primitive weapons simply do not inspire fear in advanced military minds." Marcus felt his jaw tighten. "With respect, Professor, I think you're missing something important. It's not just about the weapon itself, it's about what the weapon represents." "And what would that be?" Professor Kethvar asked, his tone suggesting he was humoring a slow child. "Adaptability," Marcus said. "When someone can fashion an effective weapon from whatever materials are available, it shows they can think creatively under pressure. That's terrifying to an enemy who relies on standardized equipment and tactics." Student Zixtra's antenna twitched dismissively. "But effectiveness requires proper materials and manufacturing. You cannot create a truly dangerous weapon from random materials." Marcus looked around the classroom, his eyes taking inventory of what was available. Standard-issue desks, made from compressed algae fiber. Chairs with metal framework. Wall panels that could probably be pried loose. lighting fixtures with focusing crystals, various personal items belonging to students. Actually, Marcus said slowly, I think I could demonstrate what I mean. If you're willing to let me try. Professor Kethvar's mandibles clicked rapidly, a sign Marcus had learned indicated intense interest mixed with skepticism. You believe you can fashion an effective weapon from classroom materials? Why, I do. The professor's forearms crossed in front of his chest. Very well, Human Chen. You have until the end of class period to prove your point. However, when you fail, you will write a 10,000-word essay on why primitive weapons are inferior to advanced military technology. Marcus nodded, already calculating angles and stress points in his mind. And if I succeed, then you will have taught us all something about human adaptability, Professor Kethvar said. Though I suspect that outcome is highly unlikely. Marcus moved to the front of the classroom, trying to ignore the whispers and chittering comments from his classmates. He knelt beside one of the desks and examined its construction. The algae fiber was dense and slightly flexible, held together with organic polymers. Not ideal, but workable. What exactly are you planning to build? Professor Kethvar asked. A bow, Marcus said simply. The classroom fell silent again. Then, student Zixtra spoke up. A bow? That is perhaps the most primitive weapon of all. Even our earliest ancestors abandoned such devices millennia ago. Marcus smiled as he began working at one of the desk panels with his fingernails, slowly separating the fibers along their natural grain. That's exactly why it's perfect. I fail to see the logic, Professor Kethvar said. Marcus continued working as he spoke. Most species abandoned bows because they developed better alternatives quickly. But humans used bows for thousands of years, constantly refining and improving them. We know every trick, every technique, every way to maximize their effectiveness. He had managed to separate a long strip of the desk material, roughly 4 feet in length and about an inch wide. It had a natural flexibility that felt promising. Marcus began carefully thinning one end while explaining his process. The key to an effective improvised bow isn't just the materials, he said. It's understanding the physics involved and working with what you have instead of against it. A Quellian student near the middle of the classroom raised a tentacle. But surely the materials are too weak to generate significant force. Marcus held up the strip he'd been working on. This algae fiber is actually quite impressive. It's designed to be lightweight but strong, with natural flexibility to prevent breakage. It's not wood, but it has similar properties. He moved to one of the chairs and began working at the metal framework where it connected to the seat. The joints were held with expandable clips rather than permanent fasteners, probably for easy maintenance. Marcus managed to work one loose, producing a piece of curved metal about 6 inches long. And this, he said, holding up the metal piece, gives me the leverage point I need. Professor Kethvar watched with growing interest as Marcus began attaching the metal piece to one end of the algae fiber strip. He was using threads pulled from his uniform to lash the metal in place, creating a small but sturdy grip point. The psychological impact I mentioned, Marcus continued as he worked, comes from several factors. First, it shows your enemy that you're never truly disarmed. Second, it demonstrates creativity and adaptability that they probably haven't encountered before. Third, it suggests that you have skills and knowledge they don't understand. He tested the flexibility of his improvised bow stave, bending it carefully to check for weak points. The algae fiber performed better than he'd hoped, maintaining its curve without cracking or splintering. But most importantly, Marcus said, moving to the wall panels, it works. He began working at one of the lighting fixtures, carefully removing the focusing crystal without damaging it. The crystal was designed to concentrate and direct light, but it could serve another purpose entirely. Student Zixtra leaned forward in her seat. What are you doing with the light crystal? Making an arrowhead, Marcus said. He placed the crystal on the floor and used the metal piece from the chair to carefully chip at its edges. Each impact was precise and controlled, gradually shaping the crystal into a sharp, pointed head. The crystal is designed to focus energy, Marcus explained. That same property that makes it good for directing light also makes it excellent at concentrating impact force. Plus, It's much harder than most organic materials. Professor Kethvar's mandibles were clicking in a rapid pattern that Marcus didn't recognize. This is quite ingenious, but you still need a projectile shaft and some method of propulsion. Marcus smiled and held up several long, straight fibers he'd extracted from the wall panels. Shaft material, and for propulsion. He pulled more threads from his uniform, beginning to weave them together into a single, stronger cord. "You're creating a bowstring from uniform threads?" Student Zixtra asked. "The uniform is designed to be durable and flexible," Marcus said. "Individual threads might be weak, but woven together properly, they can handle significant tension." As Marcus worked, he found himself falling into the rhythmic, meditative process of crafting that had been passed down through countless generations of human artisans. His grandfather had taught him to make bows during childhood camping trips, insisting that every person should know how to create tools from whatever materials were available. "This is a skill that requires patience and practice," Marcus said, carefully testing the tension of his improvised bowstring. Most species developed alternatives quickly, because they weren't willing to invest the time needed to master primitive techniques. But humans, we're stubborn. We kept working at it until we understood every aspect of the process. He attached the bowstring to both ends of his algae fiber stave, carefully adjusting the tension until the bow held a gentle curve. The whole assembly looked crude compared to the sleek, manufactured weapons displayed in the holographic presentations, but Marcus could feel the potential energy stored in the bent stave. "Now for the arrow," he said, taking one of the longer wall panel fibers and beginning to attach the crystal arrowhead with more uniform threads. The process required delicate work to ensure the head was properly aligned and securely fastened. "The balance is crucial," Marcus explained as he worked. "An arrow that's too heavy in the front will drop quickly. Too light, and it won't maintain stability in flight. You have to account for the materials you're using and adjust accordingly." Professor Kethvar moved closer, examining Marcus's work with evident fascination. "The craftsmanship is surprisingly sophisticated for such primitive materials." "That's the point," Marcus said. "Humans learned to push these techniques to their absolute limits because we had to. We didn't have access to energy weapons or advanced metallurgy for most of our history. So, we became very, very good at making the most of basic materials and simple tools." He added small pieces of material to the back end of the arrow to serve as fletching, carefully positioning them to provide stability in flight. The improvised feathers were crude but functional, designed to keep the arrow flying straight over short distances. "But surely," Student Zixtra said, "the range and accuracy would be severely limited compared to modern weapons." Marcus knocked the arrow on his improvised bowstring and drew it back slowly, testing the tension and feel of the weapon. The algae fiber bow creaked softly but held its form, storing energy in the bent stave. "Range and accuracy depend on the archer as much as the bow," Marcus said, "and sometimes, close range is exactly what you want." He aimed at a spot on the far wall, about 30 feet away, where a circular wall panel provided a clear target. The distance was well within the capabilities of his improvised bow, and Marcus had been shooting targets at that range since he was 10 years old. "The psychological impact," Marcus said, still holding the drawn arrow, "comes from the fact that your enemy suddenly realizes they're facing someone who can create effective weapons from classroom furniture. Someone who has skills and knowledge they don't possess. Someone who might have other surprises they haven't thought of." Professor Kethvar's 4 eyes were fixed on the drawn bow. "And you believe this would truly affect an advanced military mind?" Marcus smiled. "Professor, how are you feeling right now?" The classroom was dead silent. Every student was staring at Marcus and his improvised weapon. Professor Kethvar's mandibles had stopped clicking entirely, and his usually confident posture seemed slightly more tense. "I find myself reassessing certain assumptions," the professor admitted slowly. "Exactly," Marcus said. "Because now you're not just looking at a primitive weapon. You're looking at proof that I can think in ways you didn't expect. You're wondering what else I might be capable of. You're questioning whether your standard tactics and defenses would work against someone who approaches problems from a completely different angle." He lowered the bow without shooting, carefully releasing the tension on the string. "That's the real power of adaptability. It's not just about the weapon itself, it's about forcing your opponent to realize they might not understand you as well as they thought they did. The classroom remained silent for a long moment. Then Professor Kethvar began clicking his mandibles in a slow, rhythmic pattern that Marcus recognized as deep thought. "Human Chen," the professor said finally, "I believe you may have just demonstrated something far more significant than primitive weapon construction." Marcus nodded and began carefully disassembling his improvised bow. "Humans call it thinking outside the box. We've had to do it for survival for most of our history. It's become part of how we approach problems." Student Zixtra raised a tentacle hesitantly. "But surely this is not applicable to modern military situations. Contemporary warfare involves energy shields, kinetic barriers, advanced targeting systems." Marcus looked up from his disassembly work, all of which are designed to counter expected threats. But what happens when someone approaches the problem from an angle the designers never considered? Professor Kethvar's eyes widened slightly. "You're suggesting that adaptability itself is a tactical advantage." "I'm suggesting that humans have been forced to develop adaptability as a survival trait," Marcus said. "While other species were developing advanced technology, we were learning to make do with whatever we could find. We became listen now, Arkeem, very good at creative problem solving." The professor moved to the holographic display controls and brought up a new image. A standard Federation military engagement scenario. "Show me," he said. "How would this human adaptability apply to a real tactical situation?" Marcus studied the hologram, noting the positions of forces, terrain features, and apparent objectives. It was a fairly standard scenario. Two forces of roughly equal technological capability facing each other across open ground, with the goal of controlling a strategic position. "First question," Marcus said. "What assumptions are built into this scenario?" Professor Kethvar's mandibles clicked with interest. "Explain what you mean." "Both forces are using similar tactics and equipment. They're engaging at expected ranges with conventional formations. They're fighting the kind of battle that military doctrine says they should fight." Marcus moved closer to the hologram. "But what if one side doesn't follow the expected pattern? What if they use unconventional materials, unexpected tactics, improvised solutions that the other side hasn't prepared for?" "Give me a specific example," Professor Kethvar said. Marcus studied the terrain in the hologram. "The strategic position is on high ground, protected by energy shields, and defended by conventional forces. Standard doctrine would call for a frontal assault or flanking maneuver, right?" "Correct. But what if instead of attacking the position directly, you attack the assumptions behind it?" Marcus pointed to what looked like a water source near the defended position. "That water supply is probably filtered and purified by standard equipment. Equipment that's designed to handle known contaminants and threats." Professor Kethvar leaned closer. "Continue." "Humans spent thousands of years dealing with biological warfare, chemical contamination, and environmental hazards. We know dozens of ways to make water undrinkable using materials that wouldn't show up on standard sensors. Plants, minerals, organic compounds that occur naturally but become toxic in combination." The classroom was completely silent now. Marcus could feel the weight of attention from every student as he continued. "You don't attack the position directly. You make it impossible to hold. You force the defenders to abandon their advantages and fight on your terms, using methods they weren't trained to counter." Student Zixtra's antennae were twitching rapidly. "But that would require extensive knowledge of biochemistry and environmental science." "Or," Marcus said, "the kind of practical survival knowledge that humans developed over thousands of years of dealing with hostile environments, using only basic tools and natural materials." Professor Kethvar was staring at the hologram with a completely new expression. "You're suggesting that human military doctrine would emphasize unconventional warfare and adaptive tactics." "Love, I'm suggesting that humans approach conflict differently because we've had to," Marcus said. "While other species were developing energy weapons and shield technology, we were learning hundreds of ways to survive and fight with whatever happened to be available." The professor manipulated the hologram controls, bringing up additional scenarios. Show me more examples. Marcus found himself warming to the subject, drawing on military history lessons and survival training he'd absorbed throughout his life. He described scenarios where human forces might use improvised camouflage, jury-rigged communications equipment, or weapons fashioned from industrial materials. The key is that human tactics would be difficult to predict because they're based on creative problem-solving rather than standardized doctrine, Marcus explained. Every situation would be approached as a unique challenge requiring a custom solution. But surely, a Corellian student interjected, such improvised methods would be inferior to properly designed and manufactured military equipment. Marcus smiled. Inferior in raw capability, maybe, but superior in unpredictability. And sometimes, unpredictability is more valuable than raw power. He gestured toward the improvised bow components still scattered on his desk. That bow I just made would be useless against modern armor or shields, but it represents something that military planners have a hard time accounting for: the ability to create unexpected solutions from available resources. Professor Kethvar had been quiet for several minutes, manipulating the holographic scenarios and studying different tactical possibilities. Finally, he looked up at Marcus with an expression of genuine respect. Human Chen, I owe you an apology. I believed I understood the limitations of primitive warfare. Instead, you have shown me that I failed to understand its true nature. Okay, the professor addressed the entire class. What we have witnessed here is not just weapon construction, but a demonstration of a completely different approach to tactical thinking. An approach that may give humans significant advantages despite their technological limitations. Marcus began gathering the components of his improvised bow, carefully returning classroom materials to their proper places. It's not that humans are superior fighters, Professor. We've just had to become very good at making the best of whatever situation we find ourselves in. And that, Professor Kethvar said, his mandibles clicking in what Marcus now recognized as deep admiration, may be one of the most valuable military skills in the galaxy. The class period was nearly over, but Marcus could see that every student was still completely focused on the discussion. The demonstration had clearly challenged assumptions that went far beyond simple weapon construction. For your assignment this week, Professor Kethvar announced, I want each of you to research the military history of a species that relied heavily on adaptive and unconventional tactics. Pay particular attention to how they overcame technological disadvantages through creative problem-solving. As students began gathering their materials and preparing to leave, Professor Kethvar approached Marcus directly. Human Chen, I would like you to consider presenting a guest lecture to our Advanced Tactical Studies course next week. I believe your perspective on adaptive warfare would be extremely valuable to our senior students. Marcus felt a surge of pride mixed with nervousness. I'd be honored, Professor. Though I should mention that what I demonstrated today is fairly basic by human standards. Most humans could do something similar given the same materials and circumstances. Professor Kethvar's 4 eyes widened. Most humans possess these improvisation skills? To some degree, yes. It's considered basic preparedness knowledge. My grandfather used to say that a human who can't make tools from available materials is a human who hasn't been paying attention. The professor's mandibles clicked rapidly. I see that I have much more to learn about human capabilities. Your species may be far more formidable than anyone in the Federation currently realizes. As Marcus packed up his belongings and prepared to leave, he reflected on how the day had unfolded. He'd come to class expecting another lecture about human technological inferiority. Instead, he'd ended up demonstrating capabilities that even he hadn't fully appreciated before. Walking across the academy grounds toward his dormitory, Marcus began thinking about the broader implications of what had happened. If a simple, improvised bow could challenge assumptions about human capabilities, what other surprises might his species have in store for the galaxy? The academy's evening lights were beginning to activate as Marcus reached his quarters. He had studying to do for tomorrow's classes, but his mind kept returning to Professor Kethvar's final comment. Maybe humans were more formidable than anyone realized. Maybe their late arrival to galactic civilization wasn't a sign of inferiority, but simply evidence that they'd taken a different path to get there. As he settled down to work on his tactical analysis homework, Marcus found himself smiling. Tomorrow's classes were going to be very interesting indeed. The Academy's Advanced Tactical Studies classroom was packed beyond capacity. Word of Marcus's demonstration had spread through the student body like wildfire, and now cadets from multiple species and academic tracks were crowding into whatever space they could find. Marcus stood at the front of the room, trying not to let his nervousness show as he faced the largest audience he'd ever addressed. Professor Kethvar had introduced him simply as Human Chen, who will be sharing insights on adaptive warfare techniques. The professor's forearms gestured toward Marcus, with obvious respect, a dramatic change from the dismissive attitude of just 1 week ago. "Before we begin," Marcus said, his voice carrying clearly through the packed room, "I want to establish something important. What I'm going to show you isn't advanced human military doctrine. These are basic survival skills that most humans learn during their education. The fact that they seem remarkable to you says more about the differences between our species than about any special human capabilities." A Thraxian cadet in the front row raised one of her arms. "But surely these improvisation skills require extensive training and specialized knowledge?" Marcus shook his head. "They require a certain mindset more than specialized knowledge. Humans call it making do with what you have. It's born out of necessity rather than advanced planning." He moved to the equipment table that Professor Kethvar had prepared for the demonstration. The selection of materials was deliberately limited. Basic classroom furniture, some electronic components, standard-issue uniform items, and common academy maintenance supplies. "Today I'm going to show you how human tactical thinking approaches a specific scenario," Marcus said. "The situation is this. You're a reconnaissance operative who has been captured and imprisoned in a standard detention facility. Your equipment has been confiscated, but you've been left in a holding room with basic furniture while your captors decide what to do with you." Marcus gestured to the materials on the table. "These represent typical items you might find in such a situation. Your goal is escape and evasion, but your captors will be checking on you periodically. Any escape attempt needs to account for their surveillance and security procedures." A Quellian cadet near the middle of the room raised a tentacle. "What are the assumed capabilities of the security systems?" "Standard Federation-level technology," Marcus replied. "Motion sensors, periodic visual checks, basic energy barriers on doors and windows. The kind of setup designed to hold prisoners who might have conventional lockpicking tools or basic weapons, but nothing exotic." Marcus picked up a section of chair framework and examined it carefully. "The first principle of human escape tactics is that every object has multiple potential uses beyond its intended function. This chair leg, for example, isn't just structural support." He began working at the joint where the leg connected to the seat, using techniques he'd learned from his father, who had been a maintenance engineer before joining the colonial service. The joint was held with a standard expanding fastener, designed for easy disassembly during repairs. It's also a lever, a probe, a weapon, or part of a larger tool, Marcus continued, as he worked. "The key is understanding the physical properties of materials and how they can be manipulated." Within minutes, Marcus had disassembled the chair into component parts, metal framework pieces of various lengths, padding material, and fabric covering. Each piece was laid out systematically on the table. "Organization is crucial," Marcus explained. "You need to know exactly what resources you have available before you start planning. Improvisation doesn't mean random experimentation." Professor Kethvar moved closer to observe. "What is your specific escape strategy?" Marcus held up 2 of the metal framework pieces. "Patience. Security systems are designed around predictable behavior patterns. They expect prisoners to either attempt immediate escape or settle into passive waiting. They're not prepared for someone who appears to be waiting passively while actually preparing methodically." He began connecting the metal pieces using fabric strips torn from the chair covering, creating what looked like a simple repair project. To casual observation, it would appear that Marcus was trying to fix the chair he had broken. "Disguised preparation," Marcus said. "Your captors see someone trying to repair furniture out of boredom or anxiety. What they don't see is someone building specialized tools. The improvised construction was taking shape. A telescoping probe with a fabric-wrapped grip and a small hook fashioned from bent metal. It looked innocuous, like something a prisoner might make to occupy time. But Marcus knew it was designed for a specific purpose. Human children learn a saying, Marcus said as he worked, hide in plain sight. Sometimes the best camouflage is doing exactly what people expect, while actually doing something completely different. A Zilari cadet clicked his mandibles thoughtfully. But surely the guards would eventually notice unusual activity? Marcus smiled and moved to the room's ventilation grate, which was positioned about 8 feet above the floor. That depends on how you define unusual. He used his improvised tool to probe carefully at the grate's mounting points. Working from below, where the motion would be less obvious to surveillance sensors. The tool was designed to look like he was simply stretching or examining the ceiling out of boredom. Federation standard detention facilities are designed with specific assumptions, Marcus explained. They assume prisoners will try to overcome security systems directly, or attempt to break through physical barriers. They're not designed for someone who understands the difference between the security system and the building that contains it. The grate's mounting points were standard universal fasteners, designed for maintenance access rather than security. Marcus's improvised tool was able to manipulate them slowly and quietly, working at angles that would be difficult for overhead sensors to detect. The psychological aspect is just as important as the physical techniques, Marcus continued. Your behavior has to remain consistent with what your captors expect. If you suddenly become calm and purposeful after being agitated, they'll notice. But if you gradually shift from agitation to what appears to be resigned boredom, that fits their predictive models. Professor Kethvar was watching the demonstration with obvious fascination. You're manipulating their expectations as much as the physical environment. Exactly, Marcus said. Humans learned early that direct confrontation isn't always the best approach. Sometimes, it's more effective to let your opponents think they understand your capabilities and intentions, while actually working toward completely different goals. Marcus had managed to loosen 2 of the grate's mounting points without creating any obvious visual changes. From the guard's perspective, nothing had happened except a prisoner engaging in fidgety, nervous behavior. Time management is crucial in any escape attempt, Marcus said. You need to complete your preparation between guard checks, but you also need to allow for unexpected delays or complications. Humans call this building in slack. He moved away from the ventilation work and began what appeared to be nervous pacing, actually using the movement to survey the room's layout and identify additional resources. A loose floor panel near the wall, a light fixture with accessible wiring, cleaning supplies left in a corner. The next principle is redundancy, Marcus explained. You never rely on a single escape method because something will always go wrong. You need primary plans, backup plans, and contingency options for when everything fails. Marcus began working with the cleaning supplies, mixing common detergents in ways that produced mild chemical reactions. The combinations weren't dangerous, but they created useful byproducts. A paste that could corrode certain metal alloys, a solution that would temporarily disable electronic sensors, and a mixture that produced a mild smoke when heated. Basic chemistry knowledge, Marcus said. Every human learns how different household chemicals interact, usually to avoid accidentally creating toxic combinations. But that same knowledge can be applied constructively when needed. 2. The Thraxian cadet in the front row leaned forward. Where do humans acquire this chemical knowledge? Mandatory safety education, Marcus replied. When you live on planets with limited industrial infrastructure, everyone needs to understand how to safely handle and combine basic chemicals. It's considered essential knowledge for anyone who might need to perform emergency repairs or maintenance. Marcus was carefully concealing his chemical preparations within the improvised chair repair project, creating what looked like a messy but harmless attempt at amateur engineering. The reality was a sophisticated escape kit disguised as the nervous activity of a bored prisoner. Timing becomes critical as you approach the execution phase, Marcus said. You need to know your guard's routine well enough to predict their behavior, but you also need to be prepared for variations in that routine. He moved back to the ventilation grate, using his tools to complete the loosening process, while appearing to examine the ceiling fixtures with idle curiosity. The grate was now held by only one mounting point, but still appeared completely secure. The psychological pressure on guards increases over time, Marcus explained. They start with high alertness, but gradually become more routine in their checks as nothing happens. That complacency is what you're waiting for. Professor Kethvar checked his chronometer. How long would this preparation process typically require? For a situation like this, probably 6 to 8 hours of patient work, Marcus said. Human escape tactics prioritize careful preparation over quick action. We've learned that rushing usually leads to capture, while patience often leads to success. Marcus had moved on to working with the loose floor panel, using his metal tools to carefully widen the gap enough to access the space beneath. The work looked like nervous fidgeting with existing damage rather than deliberate manipulation. Infrastructure knowledge is crucial, Marcus said as he worked. Buildings are designed for specific functions, but they're also constrained by practical considerations like maintenance access, utility routing, and structural requirements. If you understand those constraints, you can predict where vulnerabilities exist. The space under the floor panel contained utility conduits and structural support elements, typical of Federation standard construction. Marcus was able to identify power routing, communication lines, and what appeared to be waste management connections. Now, you're gathering intelligence about the facility itself, Marcus explained. Understanding how the building functions gives you options that pure lockpicking or barrier breaking doesn't provide. Marcus demonstrated how to trace utility lines without actually interfering with them, learning the layout of systems beyond the immediate detention area. The technique required patience and careful observation, but provided information that could be crucial for planning escape routes. You're mapping the entire facility through its infrastructure, Professor Kethvar observed. Exactly, Marcus said. Humans developed these techniques because we often found ourselves in situations where we needed to understand complex systems without proper documentation or training. You learn to read a building like a book if you pay attention to how its components relate to each other. Marcus had traced the power routing to what appeared to be a main distribution point somewhere below the detention level. The communication lines ran to a different location, probably a central monitoring station. The waste management connections suggested the facility was designed to handle a much larger population than its current prisoner capacity. That information tells you several important things, Marcus explained. The facility is either oversized for its current function, or it serves multiple purposes. The power and communication systems are centralized, which means they're vulnerable to single-point failures. And the waste management capacity suggests there are areas of the building that aren't currently in use. A Corellian cadet raised a question. But how do you exploit that information without triggering security responses? Marcus smiled and moved back to his chemical preparations. That's where the timing and psychology become critical. You wait for the right moment, then create multiple simultaneous problems that overwhelm your captor's ability to respond effectively. He demonstrated how the chemical mixtures could be deployed in sequence. The sensor-disrupting solution applied to surveillance equipment during a routine check, the metal corrosive used on structural elements that weren't immediately visible, and the smoke-producing mixture activated as a distraction during the actual escape attempt. The key is making your captors think they're dealing with random equipment failures rather than deliberate sabotage, Marcus explained. If they realize someone is actively working against their systems, they'll respond with increased security measures. But if they think they're dealing with maintenance problems, they'll respond with repair teams and relaxed alertness. Marcus had assembled what looked like a completely innocent collection of repaired furniture and nervous fidgeting, but was actually a sophisticated escape kit. The improvised tools could disassemble barriers, the chemical preparations could disable security systems, and his intelligence gathering had revealed multiple potential escape routes. The final phase requires split-second timing and absolute commitment, Marcus said. Once you start the sequence, you can't hesitate or second-guess your decisions. Everything has to unfold exactly as planned. Professor Kethvar studied the assembled materials with obvious respect. This level of preparation suggests extensive training and experience. Actually, It suggests basic human education, plus the kind of creative thinking that humans develop out of necessity, Marcus replied. Most humans could devise something similar, given the same time and materials. We've been forced to become very good at solving problems with limited resources. A student near the back of the room called out a question. But what if the security systems are more advanced than you expected? What if your assumptions about the facility are wrong? Marcus nodded approvingly. Excellent question. That's why redundancy and adaptability are so important in human tactical thinking. You plan for your plan to fail. He began demonstrating alternative approaches using the same materials, different chemical combinations, alternative uses for the improvised tools, backup methods for gathering intelligence about facility layout. Each variation was designed to handle specific failure scenarios. Humans have a saying, "No plan survives contact with the enemy," Marcus explained. So we don't rely on plans working perfectly. We develop capabilities and techniques that can be adapted in real time as situations change. The demonstration had taken most of the class period, but Marcus could see that every student was still completely engaged. The techniques he'd shown challenged fundamental assumptions about security, surveillance, and prisoner control. The broader lesson, Marcus said, is that human tactical thinking emphasizes understanding systems rather than overpowering them. We look for elegant solutions that turn an opponent's strengths into weaknesses. Professor Kethvar moved to address the class. What Human Chen has demonstrated represents a completely different approach to tactical problem solving. These techniques would be extremely difficult for standard security protocols to counter because they exploit assumptions built into the design of those protocols. Marcus began carefully disassembling his escape preparations, returning the classroom materials to their original configurations. It's not that these techniques are superior to advanced technology. They're just based on different assumptions about how problems should be approached. As students began filing out of the classroom, Marcus could hear intense discussions in multiple alien languages. The demonstration had clearly given them new perspectives on tactical thinking and security vulnerabilities. Professor Kethvar approached Marcus as the room emptied. Human Chen, I believe you've just revolutionized how we think about unconventional warfare. Would you be willing to present these concepts to the Academy's senior faculty? Marcus felt a mixture of pride and concern. I'd be honored, Professor, but I should point out that these are fairly basic techniques by human standards. If this seems revolutionary, it might suggest that the Federation has some significant blind spots in its security thinking. The professor's mandibles clicked thoughtfully. Indeed. Which makes it all the more important that we understand human capabilities before we encounter them in actual tactical situations. As Marcus gathered his belongings and prepared to leave, he reflected on the implications of the day's demonstration. If basic human survival skills could expose vulnerabilities in Federation security systems, what would happen when humans began developing military doctrines specifically designed for galactic-level conflicts? Walking across the Academy grounds in the evening light, Marcus began to suspect that humanity's integration into galactic civilization was going to be far more complex and challenging than anyone currently realized. The Academy's Grand Assembly Hall had never hosted a gathering quite like this one. Representatives from 12 different species sat in carefully arranged sections, their various forms of note-taking equipment, creating a subtle symphony of clicks, hums, and electronic chirps. At the center of it all, Admiral Vexitani of the Galactic Defense Council leaned forward in her hover chair. Her 6 eyes focused intently on the human cadet standing at the presentation podium. Marcus Chen had not expected his classroom demonstration to escalate to this level. What had started as a simple response to a professor's challenge had somehow become a formal presentation to the highest levels of Federation military leadership. The weight of responsibility felt crushing, but Marcus forced himself to focus on the task at hand. Distinguished members of the Defense Council, Marcus began. I've been asked to demonstrate how human tactical thinking might apply to large-scale military scenarios. Before I begin, I want to emphasize that I'm not a military strategist or professional soldier. I'm a cadet sharing perspectives based on basic human education and cultural background. Admiral Vexitani's translator device rendered her response in crisp standard. Human Chen, we understand your limitations. However, Your previous demonstrations have revealed tactical approaches that our best military minds failed to anticipate. We need to understand whether these represent isolated innovations or systematic differences in human strategic thinking. Marcus nodded and activated the holographic display system. The first scenario materialized above the assembly. A standard fleet engagement involving two roughly equal forces positioned across a contested star system, with the objective of controlling a critical supply depot on the system's fourth planet. This scenario represents typical galactic military doctrine, Marcus said. Force-on-force engagement with clear objectives, standardized formations, and predictable tactical patterns. Both sides understand the rules of engagement and operate within accepted strategic frameworks. He manipulated the display controls, highlighting various elements of the scenario. Federation forces here, with standard heavy cruiser formations supported by fighter wings and defensive screens. Opposition forces here, with similar capabilities and positioning. The engagement would traditionally focus on technological superiority, numerical advantages, and execution of established tactical doctrine. A Thraxian general raised one of her arms. This scenario has been analyzed extensively by our strategic planning division. The optimal approach is clear. Concentrate superior firepower at the enemy's weakest point, while maintaining defensive integrity elsewhere. 4. Also 2-14-6. Also 2-3, Marcus smiled slightly. That's exactly what human tacticians would expect you to do, and that expectation would form the foundation of our counter-strategy. He began modifying the holographic display, adding new elements that hadn't been part of the original scenario. Human military thinking starts with a different question. Instead of asking, how do we win this engagement? We ask, why are we fighting this engagement at all? The display now showed additional information. Supply routes throughout the system, civilian populations on various planets and stations, industrial facilities that supported military operations, and communication networks that coordinated fleet movements. The supply depot isn't just a military objective, Marcus explained. It's part of a larger economic and logistical network. Human strategy would target that network, rather than fighting for control of a single point. Admiral Vex's eyes narrowed. Elaborate on this approach. Marcus highlighted the supply routes connecting the depot to other facilities throughout the system. Instead of attacking the depot directly, human forces would likely target the infrastructure that makes the depot valuable. Transport routes, communication relays, fuel production facilities, and maintenance stations. He demonstrated how relatively small forces could disrupt multiple supply lines simultaneously, using improvised weapons and unconventional tactics. The goal isn't to destroy enemy ships in direct combat, it's to make their position untenable by eliminating their logistical support. But surely, a Quellian admiral interjected, such tactics would violate established rules of engagement regarding civilian targets and infrastructure. Marcus paused, considering how to address this sensitive point. Human military history includes extensive experience with conflicts where traditional rules of engagement weren't mutually observed. We've learned that adherence to conventional limitations can become a tactical disadvantage when facing opponents who don't share those limitations. The assembly hall became very quiet. Marcus could sense that he was approaching dangerous territory, but the question demanded honest analysis. That doesn't mean humans disregard ethical considerations, Marcus continued carefully. It means we've developed tactical approaches that account for the possibility that our opponents might not share our ethical framework. Admiral Vexitani gestured for him to continue. Explain how this applies to the current scenario. Marcus modified the display again, showing how human forces might use civilian traffic patterns to mask military movements, how commercial facilities could provide cover for military operations, and how disruption of essential services could force enemy forces to divert resources from combat operations to humanitarian concerns. The psychological pressure is just as important as the tactical advantage, Marcus explained. When your opponents realize they're facing someone who thinks in fundamentally different terms, it forces them to question all their assumptions about how the conflict will develop. A Zalari general clicked his mandibles thoughtfully. You're describing asymmetric warfare taken to an extreme degree. We're describing warfare as it actually exists, Marcus replied. Symmetric engagements between equally matched forces operating under identical doctrines are actually quite rare in human military history. We've learned to assume that every conflict will involve significant asymmetries in capabilities, objectives, and constraints. Marcus brought up a new scenario: a much smaller human force facing overwhelming opposition in a defensive situation. The odds were clearly hopeless by conventional military analysis, but Marcus began demonstrating how human tactical thinking would approach the problem. Traditional doctrine would call for either immediate surrender or a heroic last stand, Marcus said. Human doctrine would call for changing the nature of the conflict itself. He showed how human defenders might contaminate their own facilities to deny them to attackers, how they might use improvised weapons to target enemy logistics rather than engaging in direct combat, and how they might leverage environmental factors that enemy forces hadn't considered. The goal is to make victory more expensive for your opponents than they're willing to pay, Marcus explained. Even if you can't win in conventional terms, you can make the cost of their victory unacceptable. The demonstration showed human forces using everything from biological warfare to environmental manipulation, turning defensive positions into extended campaigns of attrition that gradually wore down superior enemy forces. Admiral Vextani was studying the tactical displays with obvious concern. These approaches would require extensive preparation and detailed knowledge of local conditions, which brings us to another key aspect of human military thinking, Marcus said. We assume that preparation time will be limited and intelligence will be incomplete. Our tactical approaches are designed to work with whatever resources happen to be available. Quote, Marcus demonstrated improvised intelligence gathering using civilian communication networks, resource acquisition through creative interpretation of abandoned or damaged equipment, and tactical coordination using methods that didn't rely on standard military communication systems. The adaptability factor becomes even more important at larger scales, Marcus explained. A human military force would expect to operate in conditions where standard doctrine doesn't apply, where equipment performs differently than expected, and where enemy capabilities exceed initial intelligence estimates. He showed scenarios where human forces continued effective operations despite losing most of their advanced equipment, their command structure, and their communication capabilities. Each demonstration emphasized creative problem-solving and adaptive tactics over technological superiority. Professor Kethvar, who had been observing quietly from the side of the assembly, raised two of his arms. Human Chen. Are these tactical approaches taught formally in human military institutions? Marcus shook his head. These approaches emerge naturally from basic human education and cultural background. Most humans learn problem-solving techniques, basic chemistry, improvised engineering, and creative thinking as part of their general education. Military applications are just specific implementations of general human capabilities. The implications of this statement rippled through the assembly hall. If basic human education produced tactical capabilities that challenged advanced galactic military doctrine, what would happen when humans began developing military institutions specifically designed for galactic-scale conflicts? Admiral Vexitani activated her personal communication device and spoke briefly in her own language before addressing Marcus again. Human Chen. We need to understand the scope of these capabilities. How many humans possess the skills you've demonstrated? Marcus considered the question carefully. Most adult humans could perform similar analyses given the same information and time for preparation. The specific techniques I've shown aren't specialized military knowledge. They're applications of skills that humans develop for civilian purposes. And how quickly could humans develop these civilian skills into formal military doctrine? Marcus felt a chill as he realized the direction of the questioning. Admiral, I think there may be some misunderstanding about human intentions. We're not developing military doctrine for galactic conflicts. We're focused on integration and cooperation within the Federation framework. Admiral Vexistani's expression remained neutral. Nevertheless, we need to understand the potential scope of human military capabilities. Your demonstrations suggest that human tactical thinking represents a fundamental departure from established galactic military doctrine. Marcus realized that his academic presentations had inadvertently become intelligence briefings on human military potential. The assembled representatives weren't just curious about innovative tactics. They were conducting threat assessments. With respect, Admiral, Marcus said carefully, I think you may be overestimating both human capabilities and human intentions. The techniques I've demonstrated are tools for survival and problem-solving, not weapons of conquest. But they could be weaponized, a Corellian general stated flatly. Marcus nodded reluctantly. Any problem-solving capability can be weaponized under the right circumstances. But the same could be said of any advanced technology or tactical doctrine. The question is whether such weaponization serves anyone's legitimate interests. Admiral Vexitani leaned back in her hover chair, her 6 eyes studying Marcus with expressions he couldn't interpret. Human Chen, you have given us much to consider. Your presentations have been illuminating. The formal tone suggested that the session was ending, but Marcus sensed that his academic demonstration had triggered something much larger and more complex than he had anticipated. Admiral, if I may, Marcus said, I hope these demonstrations haven't created unnecessary concerns about human intentions. We're genuinely committed to peaceful integration into galactic civilization. Your intentions are noted, Human Chen, Admiral Vexitani replied. However, intentions can change. Capabilities, once developed, tend to persist regardless of the original motivations behind their creation. As the assembly began to disperse, Marcus found himself surrounded by a small group of faculty members and military observers. Professor Kethvar approached with an expression of concern mixed with admiration. Human Chen, I believe you've just changed the trajectory of human-galactic relations in ways that none of us anticipated. The professor said quietly. Changed it how? Marcus asked. You've demonstrated that humans possess tactical capabilities that weren't accounted for in existing strategic planning, Professor Kethvar explained. The Defense Council will now need to reassess human military potential and adjust their policies accordingly. Marcus felt a growing sense of unease. Adjust their policies? How? Before Professor Kethvar could answer, Admiral Vexitani approached their group. Human Chen, the Defense Council will be conducting a comprehensive review of human tactical capabilities and their implications for galactic security. You will likely be contacted for additional consultation during this process. Admiral, I want to emphasize that I'm not representative of human military thinking, Marcus said. I'm a student, sharing basic educational background, not a military strategist or policymaker. Nevertheless, your demonstrations suggest capabilities that require careful evaluation, Admiral Vexitani replied. The Federation takes a proactive approach to emerging strategic challenges. As the Admiral moved away, Marcus turned to Professor Kethvar with growing concern. Professor, what have I done? You've been honest about human capabilities, the professor replied. The consequences of that honesty are now beyond your control. Marcus spent the rest of the evening in his quarters, trying to process what had happened. His simple response to a classroom challenge had escalated into a formal military briefing that might influence galactic policy toward his entire species. The improvised bow that had started it all now seemed like a child's toy compared to the forces he had inadvertently set in motion. A message indicator chimed on his personal communication device. The text was brief and official. Report to Admiral Vexitani's office at 0800 tomorrow for follow-up consultation on strategic implications of human tactical capabilities. Marcus stared at the message for a long time. Tomorrow, he would need to find a way to explain that humans were creative problem solvers, not military threats. He would need to convince galactic military leadership that human adaptability was a potential asset for Federation security, not a challenge to it. But as he prepared for what might be the most important conversation of his life, Marcus couldn't escape the feeling that the galaxy was about to discover just how formidable humans could be when they felt threatened. And that discovery might not be pleasant for anyone involved. Looking out his window at the Academy grounds, Marcus reflected on how quickly everything had changed. A week ago, he had been just another cadet struggling to prove that humans belonged in galactic civilization. Now he found himself at the center of strategic discussions that could determine the future relationship between humanity and the rest of the galaxy. The improvised bow had been just the beginning. Tomorrow, Marcus would need to demonstrate the most important human capability of all: the ability to find peaceful solutions to complex problems before those problems escalated beyond anyone's control. But as he settled down to prepare for tomorrow's crucial meeting, Marcus couldn't help wondering whether it might already be too late for peaceful solutions. The galaxy had seen what humans could do with classroom materials and basic education. Now they would want to know what humans might do with advanced technology and formal military training. And Marcus wasn't sure anyone was prepared for the answer to that question.